In this video, we're going to explain how to graph trigonometry functions. Before we start, I want to show you a really oversimplified way of how to translate this. We all know the unit circle is about angle theta, and we use this as x-axis, y-axis, and for any angle theta, we have cosine theta and sine theta, right? And our x value is cosine theta, and our y value is sine theta. So now when we're asked to graph trig functions of y equals sine theta, for example, what we're really asking to do is to take the unit circle, make a cut here. See that? I make a cut here. Now I take the unit circle, I separate that cut there, I shake it once, and that is my sine theta. And by doing so, I will have my y-axis. I didn't draw this long enough. This is my x-axis. So that's the concept behind it. And now let's see how we can do that in a more precise way. On the unit circle, every point has the coordinates cosine theta and sine theta. So if we look at the angle theta, so let's take angle 30, for example. Here's my angle theta here. Now, if I'm looking at that, theta is 30 degrees, right? And that's one input, 30. Now, I can input 45 or 60 or 360 or 725 degrees. So in other words, the input can be any degrees, any numbers. And therefore, the domain for this function, y equals sine theta, let me use red, the domain is all real numbers. So in other words, just a simple r. Okay? For range, though, we all know the range is the output, is the y. If I look at the y, what do I have? I'm looking at sine theta. Those are my y's. And it doesn't matter how many degrees. Maybe it's 725, maybe it's 1,000,000 degrees, but as soon as I calculate sine theta, the range of the y value is right here. It's between between +1 and -1. So y is less or equal to +1, greater or equal to -1. So now, if I put all of this into a coordinate of x and the y, really, the x is my theta now, right? So you notice that for theta is one rotation is from 0 to 2 pi, 0 to 360 degrees. Therefore, in this case, I highlight the 2 pi first, then all I do is I cut it into 4 parts so that each quarter here is represented by half pi. And I do the same on the negative side. So every half pi, I mark it out. The reason I do that is that these are my inputs, right? So when I'm saying I want to graph sine of sine theta, so half pi is my theta, pi is my theta, 0 is my theta, 2 pi is my theta. So let's look at these unique values. Sine 0, right? At 0 degree, sine is 0. So I'm going to mark that. So y equals, that's actually a 0. Oops, sorry about that. And then that equals 0. Now if I look at sine half pi, look at half pi right here. Sine is right here. So I've got 1. And then sine pi is right here. And I've got 0 again. And then 2/3 of pi, 3 pi over 2 is -1. So it's right here. And then at 2 pi, I'm back to 0. And if I just connect those with some curves, I would cover all these values that I'm circling right now. If you do it as precisely as a calculator or as a computer, that represents everything on the unit circle on the positive side. And I can do the same. So here I go, -1, 0, +1, 0. And I just connect the curve. There, ladies and gentlemen, we just graphed y equals sine theta. It's that easy, really is. Again, take the unit circle, untie it, shake it, put it on the x-axis and the y-axis, making sure you know x-axis represents the input of it represents theta, the angle measure. Y represents the sine, in this case, sine theta, whatever your trig function is. Okay, so it's that simple. Another trick, I added asymptotes. They're probably the most ugly asymptotes you've ever seen. But notice that all I did was I, again, went from 0 to 2 pi, then I cut it in half, I cut it in half, I cut it in half. Now, I want to show you a really easy way of graphing the reciprocal of sine theta. So y equals 1 over sine theta. By definition, this should be cosecant theta. And all you need to do is to graph the asymptotes. Then wherever you find the maximum of the sine curve, which is +1 in this case, you do this. Then you find the minimum, you do this. Find the maximum, you draw better than I do. Find the minimum, you draw better than I do. There you go. You just completed in gold the graph of cosecant theta. All right, that's really it, guys. So again, all you need to do is to take the x-axis, which is theta, draw the y-axis, let me turn them green, find 2 pi, and then I write every half pi, I write it out. Then you go, let me do blue now, then you do 0, +1, 0, -1, 0 again. And here you connect the dots, smooth out the curve. You've got same thing on the other side, 0, +1, -1, smooth it out. Now you've got a complete y equals sine theta curve. All right, let's look at the next page. This is almost exact same approach. If I ask you to graph y equals cosine theta, so your input, your domain for theta is all real numbers. Your range, if you look at the range, let's look at it. You've got 1, 0, -1, 0 again. So your range is really between -1 and 1. That's your range. So, which is, I should have written that in blue, I'm sorry. -1 and 1 in bracket. And that's why on my x and y coordinates, this is y, my x is really theta. I can never go beyond 1, and I can go below -1. Now, I already cut it into half pi. Let's look at it. every half pi. Let me see if I can use a green dot maybe. So when theta equals 0, what's my value for x? It's 1. So it has to be, I'll use black this time. Where's my pen? Sorry. It has to be 1 here. Now, if I go to here, if I go to half pi 90 degrees, my cosine is 0. So therefore, it's here. So now, really, it's the same thing. I go from positive 1 to 0. Next one, if you look at pi, x is negative 1. And then if you look at in the third quadrant, 3 pi over 2, x is 0 again. At 2 pi, x, which is cosine theta, is back to 1. So now if I connect this smoothly, this is my, this is y equal cosine theta. And then I do the same, 0, negative 1, 0, positive 1. And I will connect these very smoothly. There you go. That's a perfect y equals cosine theta graph. And an extension to that, when I do a reciprocal, y equals 1 over cosine theta, and this time I'm going to graph y equals secant theta. How do I do that? You pretty much guessed it. Find the asymptotes. In this case, the asymptotes is on the half pi's. You basically find the maximum and the minimum, and then you go like that. So now you go maximum, positive 1, minimum, positive 1, minimum, positive 1. Do not touch the asymptotes, right? And then over here, there's half of that, and over there, there's half of that. That's it. That's y equals secant theta. It's that easy. So again, remember sine theta, remember cosine theta. If you don't remember it, remember the range is always between positive 1 and negative 1. And then you just figure out sine theta always starts with 0 because it's sine 0 degrees, is 0. Then you go 0, 1, 0, negative 1, back to 0, and then complete the entire cycle of it. All right, guys, I hope this is helpful, and I will see you in class. Bye.